Okay, so it's the iGCSE intro slide. So we're looking at section 4C, work, energy, and power. Key physics then, we have work done. Work done is equal to energy transferred when we move an object a distance by applying a force. So the work done will be force times distance. Could use it for this guy, but if we're going to use it for this guy, I have to change it slightly because the work done now becomes the gravitational potential energy, which is your mass times gravity times your height. Well, think about weight equals mg. So it's a very similar formula to the work done. Work done is usually pushing stuff across the desk. Gravitational potential energy store calculation is when you're lifting something higher. We've also got the kinetic energy store. So moving objects have kinetic energy store of a half mv squared. Bit of a crazy equation. Okay, you've got to be able to rearrange that and take roots and things. So the more massive you are or faster, the more energy you contain. Now, the conservation of energy tells us that effectively, say like this little fairground ride, the little dude is in his 80-kilogram truck. The two of them together might be 80 kilograms, say. No meters per second at the top means that the kinetic store is 0, but there's lots of height from h1, so it has lots of mgh. As he drops lower, he's going faster, so he'll have more kinetic energy, but he's lost his height, hasn't he? So he's got a lower GPE, but then he might go up a little bit higher and slow down and get a different GPE and KE again. So the two can constantly change, but the conservation of energy law is always conserved. So it might end up wasted as thermal energy in the surroundings, or you get hot wheels, kind of thing, but it's got to go somewhere. Power is just when energy is delivered over a time period. So you should be able to use the idea of power, which is work done over time taken. So there you go, work, energy, power, all the key formulas.